So the biggest problem facing humanity that engineering biology can solve is the challenge of being able to do more with less, of resolving problems of scarcity, and at the same time of doing that in a balanced way, doing it in a way that can be sustainable. So I find that engineering biology is an incredibly promising way to really reconcile some big imbalances in the world. There's more people in the world, we're consuming more resources, we're, by many accounts, we're already beyond the carrying capacity of this planet in terms of water use, land use, greenhouse gas emissions, etc. And engineering biology creates the potential to use entirely different feedstocks to be able to produce some of the materials that are of great value and interest in more efficient ways. So that's what I see as the biggest opportunity, that it allows us to create new possibilities for abundance, and that can be abundance in materials, abundance in foods, abundance in industrial products or chemicals, without being as wasteful as we have been in the past, and without polluting as much as we have been in the past. The biggest challenge to realizing the vision of engineering biology, I think, is several-fold. One is it still takes a lot of infrastructure to do biology, and I think there is a very promising trend to sharing this infrastructure, to be able to rent this infrastructure, to be able to be much more efficient in this infrastructure. And there's a very positive technology trend, but I think, unlike a lot of other realms of technology, to actually be able to engineer biology on an industrial scale still requires equipment, it requires reagents, it requires space that's not your typical space. So it still is one of the more capital intensive ways of developing technology. And I think the trends are very positive, but there needs to be a lot more evolution in the toolkit and in the sharing, the accessibility of this toolkit. So that's one challenge. I think another challenge is investors need to better appreciate risk in this field. It is an emerging field, and whenever there's an emerging field like this, investors need to get warm to the idea of how to deploy capital best against it. Right now, I think there's good capital going into the picks and shovels of engineering biology, and there is more capital going into various applications of it. But that's certainly a learning curve that's in process right now. And I think there's two more areas that really would benefit. One is skill set. So it is a multidisciplinary skill set that is required to do this effectively. So it's no longer, there's not a self-contained field. And I think it's important that we educate the next generation to be able to bring together different disciplines to practice this well. And certainly in our company, we experience this. We bring together people from different disciplines, and then we have to figure out ways of communicating effectively so that we can work together effectively. And it's great to see it come together. I think it's the challenge of educating the next generation to be able to do that even more effectively. And then along with that, educating the public. There's still misperception in the public about the possibilities as well as the risks of engineering biology. And I think a lot of the misperceptions in the public may limit the acceptability or the potential of this technology. And I think there's never too much education of the public or too much communication or dialogue with the public that is possible. I think more of that is necessary, and it's necessary by the scientific community. It's necessary by the entrepreneurs and companies in the field to be transparent and interactive with the public to normalize this great new technology.